So in this video, let us look at the formulas for centroid, incentre and excentres. So first, if you have a triangle ABC, so let the vertices of the triangle be x1, y1, x2, y2 and x3, y3. So now let us say that you're asked to find the centroid of this triangle. So we know that centroid is the point of concurrency of medians. Centroid is the point of concurrency of medians. So first we draw the medians. So if you draw the median AD, so median is nothing but the line joining the vertex with the midpoint of the opposite side. So D can be written as x2 plus x3 by 2, y2 plus y3 by 2. Now we know that the centroid divides the median in the ratio 2:1. Now you know the coordinates of point D, you know the point A, you know the ratio in which the centroid divides AD. So if you apply the section formula, you get centroid is equal to x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. It is the average of x coordinates, the average of y coordinates. So that will be the coordinates of centroid. And centroid is also the center of gravity of a triangle. So if you have a triangular plate, what is the point on which you can balance the triangle? So the point of balance is nothing but the center of gravity, which can be obtained from the formula x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Next, if you go to the incentre of a triangle, incentre is nothing but the point of concurrency of the angle bisectors. So if you draw the angle bisectors of all the three angles, they intersect at a point which is called the incentre. Now how do we find the incentre of the triangle using the section formula? So in properties of triangles, we have derived certain ratios which angle bisector tends to do. So the first ratio comes from angle bisector theorem. So angle bisector theorem states that an angle bisector divides the opposite side in the ratio of adjacent sides. It is BD by DC is equal to this ratio. This length is to this length is equal to this side is to this side. It is C by B. The side opposite to vertex C is called small c. The side opposite to vertex capital B is called small b. So BD is to DC is equal to C is to B. So from this ratio we can get the coordinates of D, because we know the ratio in which D divides BC. Next, you have another formula which states that the incentre divides the angle bisector AD in the ratio. Incentre divides AD in the ratio AI by ID is equal to this length by this length is equal to the sum of adjacent sides is to opposite side. That is B plus C is to A. So if you write the same equations with respect to the angle bisector of B, so if you draw the angle bisector of B, if this is E, so AE by EC will be equal to C is to A, and BI is to I is equal to A plus C is to B. So this is how the ratio works. So using these two ratios, so you can very clearly see that you can find the coordinates of I. So using the angle bisector theorem, you can find the vertex D, and using this ratio you can find the vertices of I. So once you apply, you get the vertices of I as ax1 plus bx2 plus cx3 by a plus b plus c, comma ay1 plus by2 plus cy3 by a plus b plus c. So a times x1, here also you have cross multiplication, this side into the opposite vertex, next side into the opposite vertex, next side into the opposite vertex. So ax1 plus bx2 plus cx3 by a plus b plus c, ay1 plus by2 plus cy3 by a plus b plus c. So these are the formulas for Incentre. Now let us go for Excentre. What is Excentre? Excentre is the point of intersection of one interior angle bisector and two exterior angle bisectors. So draw two exterior angle bisectors, one interior angle bisector. The point of concurrency is called the excentre. So there are three excentres: excentre opposite to vertex A, excentre opposite to vertex B, excentre opposite to vertex C. So how do we find the coordinates of excentre? Again, you have the angle bisector theorem from which you get the point D, and the excentre theorem says that AEA by EAD is nothing but again B plus C by A, but an external ratio. So the ratio in which the excentre opposite to vertex A divides AD is again B plus C is to A, but externally. So using this ratio you can find the coordinates of excentre. So excentre opposite to A is given by minus ax1 plus bx2 plus cx3 by minus a plus b plus c, minus ay1 plus by2 plus cy3 by minus a plus b plus c. So if you want the excentre opposite to vertex A, so you have to put minus a in both numerator and denominator. So the minus comes with the terms corresponding to A. If you want EB, so you got ax1 minus bx2 plus cx3 by plus A minus b plus c. So whichever excentre you want correspond to those vertices and sides, you put a minus sign. So this gives you the formula for excentre. So I hope you have understood how to find incentre and excentres. Thank you.